So yesterday, we learned about the static route and the reap. Anyone have any doubt in the reap and the static route? Online guys?
No, sir. No, sir.
So yesterday we learned about the reap. Okay, just tell me what is the AD value for the reap?
120.
120. Sure. Default. Okay. What is the metric? Metric.
15.
It's the maximum hop count. Like
Hop.
the metric is hop.
Hop.
And maximum it will reach to the 15th router. Then what is the multicast IP address?
224.0.0.9.
224.0.0.9. Then RIP is working on which layer?
Layer 7.
Which protocol? UDP protocol. Port number?
520.
And timer. What is the hello timer?
20.
30 seconds.
30 seconds. Sure. Yeah. And invalid timer?
180 seconds.
Flush time, like hold down timer? 180. And the flush timer?
240.
240. It's around how many minutes? 4 minutes. Okay. So this was a RIP. And what is the difference between the RIP 1 and the RIP 2? In the RIP 1, what's your, like, this is your RIP 1. If you want to advertise your network, so which IP address you are using? In RIP 1. Sure.
Classful.
Yeah, classful. I asked like, with which, like, for advertising your network, which IP address you are using?
Broadcast. 255.
255. In RIP 2?
224.0.0.9.
Do you have any authentication in the RIP 1?
No.
No authentication.
No authentication.
The RIP 2 we have. Now, in the RIP 1, we have auto summary. And we can't disable this feature. Okay? But in the RIP 2, we can disable this feature. Like this, we have some advantages and disadvantages. Now, so today's first task is we have to learn about the ERGRP. And I guess yesterday I gave you one task to learn like what is the AD value and what is the metric. What is it? Food? I know what the food.
Decide destination and multiple paths. Decide the destination AD value.
Okay. Anything else? Huh? So why we are using matrix then?
If there are multiple paths,
Same concept you said, na?
No.
Same concept you said, na?
Yeah, but the concept is that like same protocol if we can use and for the same destination, that is go for the second rule, we can say check the matrix value.
Okay, online guys. Rakesh, Gita, any idea about the AD value and the metric?
AD value used to select best path,
Best
and
path.
it is depend on the AD value as per routing protocol. So
Okay. So till now we learn about the static route and the RIP. So in the static, your AD value is 1. Static AD value is 1. Okay. In the RIP, you have
120.
120. Okay. Same like we have a ERGRP and the OSPF. So least AD value is going to prefer. Okay. After ERGRP. Come to the ERGRP. So same is the dynamic routing protocol. It means we have one multicast IP address. Any idea? What is the multicast IP address for the ERGRP? IP address. 0.0. 9 already reserved for the read. So for the ERGRP, we have 10. Okay. And one more thing, like in the RIP, I told you like we have a matrix hop. Hop, what the meaning of the hop? Like this 1, 2, 3, 4. So your destination is this one, and you are here. So how many router you are jumping? You are jumping 2 or 3, something like 1, 2, and 3.
3.
So this is your hop. So till 15th router, you can advertise your network. So in the RIP, your last metric hop is 15.
15.
Is a range. Same like in the ERGRP. In some book, when you read some books, so in the book, they are saying like ERGRP is working on the hybrid protocol. Hybrid in the sense like is where it's using the hop count as well as your link speed. Like suppose you have one topology. This is your one topology. One router, 2 router, and the 3 router. Okay, this is your topology, small topology. R1, R2, and R3. I'm talking about the RIP. Do you know what is the bandwidth? Why we are using? Any idea? Bandwidth? Huh? Okay. Rakesh, any idea what is the bandwidth? Like you can say the link speed. Simply link speed, like from the R1 to R2, I have 10 Mbps speed. 10 MB per second. Okay, just tell me, this one is MB. Is a megabit or megabyte? Bits. It's a megabits or megabytes? Bytes. Just tell me what's the difference between these two statements, like MB and MB. Megabit and the megabyte. When you are purchasing any internet, so which one you are getting, the first or second? So someone say like I have 100 Mbps. It's like megabit per second, not a megabyte. So again we have to divide by 8. Why we are dividing by 8? One byte is equal to 8 bits. That's why when you are dividing by 8, then you will get the actual speed. So in this from R1 to R2, you have 10 Mbps. Okay. And from R1 to R3, you have a 500 Abps. Very super speed. Okay. So according to you, if you want to reach from R1 to R3, which path you will prefer? And here also you have 10. Means from R1 to like R2 to R3 also you have a 10 Mbps.
R2 to R3, R1, R2.
Right. According to you are going to prefer R1 to R3?
R2 to R3.
R1 to R2, then R2 to R3. Why? Because here we have a superb internet speed. But your RIP is working on the distance vector routing protocol. Note it down, I just forgot to say you. Your RIP is working on distance vector routing protocol. Huh? RIP, yeah, RIP. RIP is working on the distance vector routing protocol. Distance. And it's using the algorithm Bellman-Ford. Algorithm is using Bellman-Ford.
Yeah.
Be a double Bellman-Ford. Bellman-Ford. Ford is something like this, I guess. Yeah, let's check on the Google what is the spelling for Bellman-Ford. Algorithm with Bellman-Ford. Read. Okay. Yeah, B-A-L-L-M-A-N-Ford. Okay, Bellman. That one. Okay. This one. B-E-L-L-M-A-N. 4.
Distance vector routing protocol is
Yeah.
not.
Okay, distance vector routing protocol. What the meaning of distance is going to check your distance. So according to your RIP algorithm is working on the distance vector routing protocol. It means it's going to check the distance. So now just tell me if with the RIP, which path is going to prefer? It's going to check the distance. Directly. It doesn't matter like you have a very less speed or not. It's going to check the distance. Hop count. How many hop we have to jump for the destination? Here we have very less. So it's going to prefer from directly R1 to R2. It doesn't matter like here we have a very less internet speed. Doesn't matter. It's going to prefer this one. That's why we are not using. Wait, because here you can see I have 10 Mbps. I have super speed. I can transfer my data very fastly. Quickly, I can forward my data. But still, it's going to prefer this path. Yeah. And your OSPF is working on the link speed. But your ERGRP, in some book, they are saying like is using like working on the hybrid. It means distance vector routing protocol as well as a link speed one. Link speed. Link state routing protocol. Distance vector and the link state routing protocol. And it is working like is a hybrid protocol. It means it's working on the distance also. Means we have some hope. So in this we have 255 hope. Till the 255 router, I can advertise my networks. And it's
It is using both the distance as well as at a time or both together.
when you are using like practical in the real time is using only link state. But according to book is a hybrid. When you are performing any practicals and also will get the idea like it's using the link state protocol. But book in the book they are saying it's a hybrid.
Link state means
It's going to check the bandwidth and all. So according to ERGRP, you are going to transfer your data by this. Okay. In this we have some K values. Like in the RIP, what is your matrix? Hop. So in this we have K values. Matrix is K value. K value. We have total 5 Ks. Like K1, K2, K3, K4, K5. K1, K2, K3, K4, K5. K1, K2, K3, K4, and the K5. So the K1, it's called a bandwidth. Bandwidth, load, delay, MTU, and the reliability. Reliability. Maximum transmission unit. First one is the bandwidth, load, delay, MTU, and the reliability. Yeah. So in the normally in a ERGRP, it's using K1 and K3 value only, bandwidth and the delay. Based on this parameter, is going to calculate your matrix and is going to forward your data. Okay, bandwidth and delay. What's the meaning of delay? Like late response. When you are trying to send any data from one side to another side, you are facing some issue. Like maybe then you are transferring your data from the router to router. So maybe you have a very older router. It means you have very CPU issue. Clock speed is very less. You are sending multiple data. So in the CPU, like in your PC also, when you are running any game, high level game or any heavy software, so it's going to utilize your CPU and all. If you have a very low clock speed, so maybe it will take some time. Same like in the router, if you have a low clock speed, low CPU, then it's going to take some time. Then also your storage. If I'm getting lots of data, so I need some storage to store that data. So if I have very less amount of the storage, then maybe your packet will be lost. So this is the delay, like due to the processing speed, due to the queuing speed, queuing delay, we have lots of delay. In the quality of service, we will learn about these things. Okay. Now, so now according to ERGRP, which path is going to prefer? This is a rate. Now, according to ERGRP, bandwidth and the delay and all is going to check. So from the R1, R2, and R3, we have superb speed. So in some scenario, it's going to transfer this file from the here. Okay. Now, the configuration is remains same. This is a theoretical part, like ERGRP is using 224.0.0.10. It's a hybrid. It's using link state and the also distance vector. That's why we are saying is a hybrid. It's using multiple protocols and all. And yeah, algorithm. So for the RIP, we have Bellman 4. So for the ERGRP, we have a dual, DUL, diffusion algorithm. I don't know how they are mentioning this name. Dual Bellman 4, diffusing algorithm. This one, DIFFUSING, diffusing update algorithm. Dual. Okay. Diffusion update algorithm. And in this ERGRP also we have some timer. So we have only two timers. Hello timer and that timer. Hello and that. Hello and that or that. Hello is a 5 second and that or DATH 50 multiplied by 3. And we can change these numbers also, but not in CCNA, in the CCI. CCI or the CCNA. You can change your timer and okay.
There is a delay in the first round.
Huh?
Which part it will consider if there is a delay in the first round?
So there is one calculation. There is one calculation in the ERGRP. According to that calculation, is going to check which path I have to select. There is a calculation. ERGRP is very large topic. When you come for the CCNA, so this ERGRP, it will take around 4 days. Only for the ERGRP. For the OSPF, 1 week. 1 week. And we will done within one class. Yeah. It's just a CCNA. So I have to just introduce you, like what is a ERGRP? Our ERGRP is not included in the CCNA, they removed. But for the knowledge purpose, we have to learn what is a RIP and the ERGRP. Okay, clear? So now, practical. So now just tell me, how can I advertise? Like I have one router. Okay. In the router, I have two networks. 192.168.1.0 and 1.10.0.0/24 and this /24. Okay. Now with the RIP, how can I advertise these two networks? What is my first command? Router RIP. Router RIP. Then we have some version like version 1, version 2. So we have to select version. Version 2. Then no auto summary. Why we are firing no auto summary? If you are advertising 10 networks, so it's considering like it is a class A, so it will advertise with the slash side. But we said like that 24. So we have to disable this feature. No auto summary. Okay. Then we have to advertise our network. What is the command? 192.168.1.0 network 10.0.0.0 like this. Okay. So same like with the ERGRP. Again, instead of the RIP, we have to mention our ERGRP, no auto summary, then network. But here we'll get the wildcard mask. Wildcard entry. So in the year like networking, wildcard mask is a reverse of your subnetting. So if suppose you're subnetting like 255.255.255.255.0. So what's the reverse of this value?
0.0.0.255.
This is your wildcard mask. Reverse of your subnet. Okay. Start your Cisco packet tracer. Do you know what is IoT and all? Anyone? IoT? Where are you?
Internet of Things.
Example. No, it's not. It's not a. My laptop is connected with the Wi-Fi. But it's a smart device already. Okay? Where? You know, like when we are clapping, so our fan is on, clapping, so our fan is turned off. Then your this is IoT. 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 Internet on things, something. Internet of things. Okay, so take a 3 routers. 4 routers.
Let's see.
So this is my topology. It's visible. I need in the one network or different network, doesn't matter. Like this. Number 1 to 2, 2 to 3, and 3 to 4. So here I am going to use network. 192.168.1.0/24. Here 172.168.1.0/24. And here 0.0/24. Now we have to do some basic configuration. So not bad. So this is your router 1. Now just tell me the router 1, which command we have to fire? Huh? We have to configure our IP address first. Enable, then config, then change the host name R1, then interface 0/0, then IP address 68.1.255.255.255.0. Down, exit. Done. Router 2, host name is router 2, F0/0.2, then interface F0/1, then IP address 172.168.1.2, 255.255.255.0. Then router 3, the router 3 F0/0 is connected with the 172 network. .3, and here 10 network 10.0.0.3. Okay. Then router 4, last one. So router 4 10.0.0.4. Okay. This is our IP addresses. Copy, come to the router 1, CLI, the best, R1, then R2. R3. The last R4. Okay, there's some There is some issue, I guess. I guess I still have some issue with the router 3. Oh, no set command. Okay, okay. Here, no set command. Done. Done. Here also. Interface F0 by 1 and then no set command. Okay. Now, do one thing, just create one loopback in the router 1 later. Now come to the router 1. We have to configure our routing protocol. So first, router, which protocol? ERGRP, Enhanced Interior Gateway Routing Protocol. ERGRP. But here we have some autonomous system. AS number. So we have like if this is my one network, one organization. So here we have to mention the AS number. Same AS number we have to assign in each and every router. We can use a different AS number also, but AS number like within a one admin, there is all router, 4 routers are handled by the only one admin. If you are changing your AS number, it means it's not belongs to my area, it's a different network. For that, we have some different concept. So as of now, mention the same AS number. So 10. Then auto summary. Here also we have an auto summary. So just far, no auto summary. The next, we have to advertise our network. Network only we have one network 192.168.1.0. Space give question mark. So it's asking for the wildcard mask. So what is the wildcard mask? 0.0.0.0.255. But here if you are using subnet mask, so it will work here. But they are asking for wildcard mask. So just assign the wildcard mask. The wildcard mask, like we can segregate our networks and all. If I am advertising, here I have 192.168.1.0 network. In the router 2, on the first in like on the F0 by 0, I am using 192.168.1.0/30. On the F0 by 1, I am using 192.168.1.4. If you are using your RIP protocol, so we don't have any that subnet mask and all. So directly I can assign 192.168.1.0. So it will consider like this is a class A, class B, something. That's why with the subnet mask we can divide our networks. So here they are asking wildcard mask. Yeah, one more question I have. So I advertise my ERGRP here. Okay. Now also in the router 2 also I'm going to advertise my network. That's it. First check the your network information. Do so IP interface B. 2 networks we have. Okay. So router ERGRP as number 10. Summary. Network 192.168.1.0. Neighborship. It means this ERGRP, like now router 1 is the neighbor of the router 2. Okay. So now on this router, on the router 2, I advertise only one network. Okay. Now come to the, actually here we have 2 networks, but I advertise only one network. Now come to the router 3. Now try to advertise your entire network. Router, ERGRP, and network 172.168.1.0 space 0.0.0.255. Then second network 10.0.0.0 space 0.0.0.255. This one. Now just tell me, do we have a 192 network information in this router or not? Yes or no? I configure my ERGRP protocol in this router. I advertise 192 network. I configure ERGRP routing protocol in this router also, and I advertise this network. Okay, I advertise only this network. In the router 3, I configure my ERGRP and I can advertise this network and this network. Now just tell me, do we have 192 network information in the router 3 or not?
No.
Why?
There is no,
Yes, yes.
Yes, we have. Okay. You? No, why?
We are defining this router 1 to router 2 on the way outside. So this information will not pass to this.
Yeah. So we don't have any information regarding the router 10. Do we have? Yes or no? No, why? Let's focus here. It's a very tricky question. So you can check this whole out. So IP route. We don't have any 192 network. Why? Because with the help of the network command, you can see this is a network command. Where is it? When you are firing the network command, network 192.168.1.0, 0.0.0.255. Okay. When you are firing this command, with the help of this command, I'm going to enable my ERGRP protocol on the particular interface, not on the router. I'm not going to enable my routing protocol on the router level. I'm going to enable my routing protocol on the interface level, not on the router level. Okay. So when you are firing network command, network 192.168.1.0. So this IP, this network belongs to which interface? For the router 2. Huh?
F0/0.
So your ERGRP routing protocol is going to enable only on this interface. Okay, not for this.
Okay.
So we have a neighborship here, but we don't have any neighborship on this area because we didn't configure ERGRP protocol on this side. So how can we make a neighborship? And if we don't have any neighbors, so how can we transfer this information to here? What is the point? Now, come to the router 2 again and try to advertise that 172 network. Network 172.16.1.0. Now you can see we got the visibility. Now come to the router 3 and check here. Neighborship up and again check. 192. Got it? This is your information. So with the help of the network command, definitely you are trying to advertise your network. But from which interface is going to check when you are firing network information. So it's going to check this network IP address belongs to which interface. On that interface, we have to enable our routing protocol. Because in a one router, we can enable multiple routing protocols. We can enable. So on this side, I can enable ERGRP. On this side, read. We can do these things. Okay. Now come to the router 4, the last, and configure your routing protocol. Router ERGRP 10. Summary. Network, which network? 10.0.0.0. Done. Okay. Maybe fine. No auto summary. No. Okay, so now come to the router 4 and check the network information. How many networks we have? So IP route. So we have 192 network. We have 172 network. And you can see here D. D means EIGRP. Where is it? Yeah, here. EIGRP. It means we receive this information from the EIGRP routing protocol. And yeah, AD value of the ERGRP is 90. There is a two ID value 90 and 170. 90 for internal, 170 for the external. Internal, it means for the same AS number. We have ID value 90. For the different AS number, we have 170. Yeah. Now check the reachability. Or do one thing, just come to the router one and configure one. Look back. Interface, look back one. By default, your interface is up state. Why? Because it's a logical. So IP address 1.1.1.1.255.255.255.255. Okay. Now, do we have this information in the router 4? I created a one loopback here. Do we have a route here?
No,
No.
we are not advertised.
Do we have a route? No, because we didn't advertise. Okay, but we didn't advertise. So how can we get the information? So again, come to the router. Here grp 10. Then fire the network command. 1.1.1.1. What is the wildcard mask for it?
0.0.0.0.
Now come to the router 4. Just do one thing. Sometime you'll get the blink. It means it's receiving some data and it's transferring some data. Okay. Now come to the router 4 and check. We have information.
What is this saying 10 via 10.0.0.3?
Via 10.0.0.3. Good question. So currently I am in which router? Router 4. Okay, just tell me that information I received from which router?
Router 1.
Router 3. I received this information. They are sending, but from where I received this information? From the router 3.
3.
What is the router 3 IP address of the F0 by 1? 10.0.0.3. Move your mouse, we'll get the idea. 10.0.0.3 means I am receiving this information from this IP address. And this IP address I reach from this interface. Okay. Now just tell me, if I want to check which routing protocol I enable in the router, what is the command?
Do show IP protocol.
So IP RGRP protocol. So IP RGRP protocol.
Show IP protocol.
IP protocol. So your protocol ERGRP 10. You can see here metric weight K1, K2, K3, K4, K5. Generally they are using K1 and the K3. Okay. And these two networks we advertise and we receive some data from these IP addresses. And our AD value we are using identity for the internal, for the same AS number. If we have a different AS number, then our this like AD value is 170. Ready? Yes, we can use it. Yeah. Like you can see, we have 5 values. It means we can use low bandwidth, low delay, and reliability. We can use up to you, up to your network. In the networking, we can do whatever you want. Okay.
Sir, 10.0.0.3 is a 0/0 for sequence. But in the topology, it is FA0/1.
I said like we receive this IP like this route from this IP address, and I can reach this IP address via this interface. This is my own interface.
Sir, hello.
Yeah.
Sir, can you open that screen, router screen?
This one.
Right. Here AD value plus some value is there 161280.
This
What
one
is
is your
that?
AD value, and this is
Huh.
your metric value. In the read when you are configuring, you will get the 1, 2, 3, 4 like this number.
Hop.
Oh, here we have a metric. This is a calculation. Bandwidth multiplied by delay, like bandwidth delay divided by 256. We have some formula. This is a very lengthy formula, and we have some more concept. These are for the CCNA.
Okay.
Because only for explaining this task now we need only entire one class. For this only particular.
Okay, no issue.
Okay. This is your ERGRP. Configure it in your router and do it quickly. For this, we have some feasible distance, advertised distance, we have to check.
Okay.
और बैंक आहे का और बैंक
So we need to do this task. It's
Yeah, yeah.
config-
You have to do
Okay.
this.
Okay, okay. Sir, can you minimize now this screen? So I will check the IPs and accordingly configure.
IP address you can select by yourself. If you don't like this 192 network, you can select 100, 200. It's up to you. Guys, you notice here we have some maximum hop count is 100. But as I told you, like we have to 55. So by default we have 100, but we can increase till that number. By default, your maximum hop count is 100, but we can increase.
Like total will consider what, router or
Router. Router.
router. One router.
We are jumping from one router to next router to next. Come on. This is just a configuration. Or for the ERGRP, router ERGRP, then then 192.68.180. That's it. Guys, done? No? Where is your laptop?
Done, sir.
Nice, nice. What about you guys, physical guys? Do it, do it. See, this is your classmate, na? I did it within a 5 minutes. You are taking so much time. Subnet, check the subnet mask, network, and all. Interface. Guys, every time just type your commands in the notepad. Then like this, you can memorize your all the commands and all. It's very helpful for you. And also, if you just copy and the paste, just restart your router, copy and paste. It's very easy then. This is the command ERGIP router, ERGIP 10, no auto summary. Then you have to advertise your network. According to your router, you have to select your network. Because in router 1, I have only one network. In the router 2, I have two networks like this. Guys, fast. We have to start our OSPF also today. OSPF. We have to start our OSPF. Done. Okay, then let's start our new topic. Okay. So your next topic is OSPF. Our main CCNA topic. OSPF. One sorted part first. OSPF. What is the AD value for the RIP? 120. For the RJRP? 90, 170. Normally 90. Okay. As OSPF, we have 110. In the OSPF, we have a two multicast IP address. 224.0.0.5 and 224.0.0.6. Okay. And is the open sorted path first. Who belongs to computer and all. Anyone know what is the algorithm? Have you heard about the Dijkstra algorithm? Why? We are using the Dijkstra algorithm.
It's a dynamic algorithm.
Dynamic algorithm. Then,
It's the shortest path.
so your OSPF is working on the link state and also it's using the algorithm, Dijkstra algorithm. Huh?
Spelling.
Yeah, tell me. Huh? Dijkstra algorithm spelling. Huh? I guess what is the algorithm spelling for the Dijkstra?
DIK say something like that.
OSPF algorithm is a Dijkstra. Better to write it down. Yeah, this one. Dijkstra algorithm. DIJKSTRN. Spelling. Algorithm. Dijkstra algorithm. Okay. It's asked to them. So AD value is 110. It's using the two routing protocols, multicast IP address 224.0.0.5 and 224.0.0.6. And it's using the Dijkstra algorithm. Then yeah, matrix cost. We have some cost, like if you have a 10 Mbps speed, then we have some specific cost and all. Specific cost. Then here, timer. So in the ERGRP we have a 5 and 15. Here we have a, what is it? We have 4 and 10, 4 and 40. Hello, it's 4 in the 14. 4 seconds. Now the in OSPF you can 40. So here you can see we have a two multicast IP address. Why they introduced two multicast IP address? No. So in OSPF, like you can see in the RIP also we have only one. In the ERGRP also we have only one multicast IP address. But here in the OSPF they introduce two things. And also in the OSPF, we have one more concept, area concept. Area. In the area, we have some area like area 0, area 1, area 2, like this, we have some area. Area 51. Also we have. So like this, we have some area. This is your area. It means in your one organization, like you have some IT department, account department. So we can divide to the areas, like this area 0, area 1, area 2. So this is your area 0, area 1, and the area 2. What the meaning of the backbone? And your body backbone?
That
Suppose if your backbone cracked, then gone, paralyzed. Like if anything happened with my backbone, so we can like paralyze and all. So in OSPF also we have area 0. Area 0. And area 0 is a backbone area. You can say it's a backbone area. It means each and every area must be connected with the area 0. If it's not connected with the area 0, it means it's paralyzed. They can't communicate with each other. So area 0 is a backbone area. And the rest of all area must be connected with the area 0. If you don't have any connectivity, directly connectivity we need. Means they are directly connected with the area 0. If you don't have any direct connectivity with the area 0, you can't communicate from one area to another area. So we have area 0, area 1, and area 2. So again, why they introduce this 2 multicast type address? In one area, like suppose you have one network. In one network, you have multiple routers. Okay, you have multiple routers in one network. This is your one network, single network. The single network, your router 1, router 2, router 3 are directly connected. It means only we have one network, 1, 2, 3, and the R4. They are directly connected. Yeah, one network. In your one network, you have some concept. Like, so suppose this is my ERGRP. So in the R1, I am going to create one network. So it's going to advertise this network to the router 2, router 3, and the router 4 also. Then router 2 receives some network, and they said, okay, I received some new network. So I'm going to advertise this networks to the routers and all. So what they are doing, they are consuming your bandwidth and all. Okay. So for overcome this kind of scenario, in the OSPF, they introduce 2 terms, DR and BDR. Designated route and designated route. So in a college time, in the school time, forget about the college time, school time, 8th standard, 9th standard, and 10th standard, we have one class monitor. Correct part. Class monitor, okay. We have one class monitor for the girls and the boys, like we have 2 components. So if you have to do some announcement and all in your classroom, so your teacher, your class teacher, your principal, they are sending message to your monitor and they are going to broadcast, like they are going to inform that information to the everyone. Okay. Same like if you are this is your class and you are the monitor. Okay. I have some issue with someone. So I'm going to tell you, like I have some issue with that. So first I'm going to reach to you, then you are going to reach to them. So in a network, I have some network. I want to advertise to all of you guys. So I want to advertise this network to my monitor, it means DR. Okay, and the DR is responsible for redistribution for the network to the rest of all guys. You are going to redistribute that network to the rest of all routers. If you are not present, you are absent, you went for somewhere. So the backup one. Okay, same like if DR is not present, then we need a backup, BDR. So I want to send my packet to the BDR, and the BDR is responsible for distributing this network. Then we need 2 things, DR and the BDR. If you are present and you are a DR and that one is a BDR. If you are absent, so he'll become a BDR and we have to find one more BDR. We need 2 things. Yes, we need a backup. Backup. Priority 1, 2, 3, 4, 5. If priority 1 goes down, then priority 2 become a DR. If priority 2 goes down, then third one become a DR, like this.
So these routers are connected with the help of the switch.
Yeah, this is one network. In one network, we have our DR-BDR. Second network, again, we have DR-BDR. Network to network. So we have a DR and the BDR. It means we have to select, like in this scenario, I have 4 routers. So I have to select who will become a DR and who will become a BDR. It means we have some election process. Huh?
Election process.
Yeah, election process. BJP or Congress. I'm a Gujarat man. Okay, so there is a one election process, DR and the BDR. So we have some parameters and all. In the real scenario, we are going to check the power, we are going to check the money and all. Who has a power and the money, he will become leader. So here also, there is a 2 parameters. Priority. First parameter is a priority. We are doing election process for the DR-BDR. Okay, it's a DR-BDR election process. So the first parameter is your priority. And the higher priority is mandatory. Like if you have a higher priority, then you will become a DR. So higher priority. And by default, in each and every router, we have a priority 1. By default, your priority is 1. And that priority is not a router priority. Again, it is an interface priority. So in each and every interface, we have a priority 1. Okay. By default, 1. Default 1. So this is your first priority, first parameter. So in this scenario, I have 4 routers. All the router priority is 1, 1, 1, and the 1. So who will become a DR? There is a tie. It means we need a tiebreaker. The second parameter. Second, we are going to check router ID and also have router ID. In the OSPF, we need a high. It's everything high. Then so what is the router ID? So for the router ID also we have one election. Okay. So here the first one is going to check your manual router ID. Like I want to assign manual router ID. Manual router ID. We can assign your router ID. Manual ID. This is our is called a router ID. This is your router ID. Router ID, it means this is the form of the IP addresses. They say router ID. Okay, router ID.
Means what is that? Who assigns? We assign or
Manually, these are 3 parameters. Manually, so you can assign the router ID. Manual. And it's formed into this one. 32 bits. That means like an IP address. Like the IP address. You can assign manually router ID. Okay. If you didn't assign manual router ID, then what? I am very lazy person. I am not going to assign the manual router ID. Then it's going to check your second parameter is a loopback IP address. And again, in the DR-BDR is going to check your higher, each and everything higher. Priority higher, router ID is higher. So if I didn't assign manual router ID, then it's going to check the loopback IP address. So suppose in your router, I created 5 loopback IP address. So it's going to check the higher one. And that higher one is become a router ID. Loopback interface, loopback 1, loopback 2, loopback 3. Logic 1. Yeah. We created a loopback 1, loopback 2, loopback 3. We can create like 215 something created. And router loopback 1 IP address is like 1.1.1. 1.1.1.1. Second is 10.0.0.14. Then 100.100.100.100. 1. So in my one router, I have these 3 loopback IP address. So it's going to check your higher one. So 100.100.100.1, it will become your router ID. If you didn't assign the loopback IP, then it's not a mandatory, like I have to assign the loopback IP. It's optional. If I didn't assign any loopback IP address, then it's going to check your interface IP, higher interface IP address. And we didn't assign the interface IP address then. If you don't have any IP address, then how can you make the routing protocol? For the routing protocol, we need some IP address. So this is the election process. First is going to check the priority. By default is 1. If your priority is equal, it means there is a tie happen in your environment. Then you have to check the second parameter, router ID. Again, so first is going to check the manual. If we didn't assign the router ID manually, then it's going to check the loopback. If we didn't assign the loopback IP address, then it's going to check your higher interface IP. Clear? So first, let's discuss about the DRBDR election. We need a verification. I can like write it down and okay, these things we have to prove. So for this, I need 2 routers. I need a proof. So router 1 and the router 2. They are directly connected. Okay. So this is your router 1 configuration and this is the router 2 configuration. See right? R1 is configured. R2 is configured. So we have only 2 routers. So according to you, and according to our concept, just tell me who will become a DR and who will become a BDR. R1 or R2? R1 is BDR. Who is a DR? DR is R1. DR is R1. First, we have to check router priority. Each and every router we have 1. Okay. What is the second priority? Second thing? Router ID. Okay. We didn't define here any manual one. First one is gone. Then second, loopback. We didn't configure in loopback IP address. Done. What is the third parameter?
Interface IP.
Who is the higher interface IP address? R2.
R2.
Become a DR. Because R2 has a higher IP address, no 192.168.1.2. Here we have 1. We have a 2. Higher. According to you, this one is a higher IP address. 1.1. Nice. Now, one more thing. Your OSPF is working on the area concept. Area. And we need area 0. So this is my area 0. This is my area 0. This is my area 0. Area 0. Okay. It means both router belongs to area 0. Let's come to the router 1. Again, router, OSPF, and this is the process ID. Same. It's not like ERGRP. It means in the ERGRP, your AS number must be same for each and every router. But this is optional. Like I can give 10, 20, 30 differently because it's not like a AS number. It's a local to that router. It's local to that router. Number. Then network. Our network 192.168.1.0. Then again wildcard. Awesome. 168.1.0. Then again wildcard mask. Now there is only one extra thing here in the OSPF. We have to define this router belongs to which area. That's it. This router belongs to which area? So just we have to type area 0. That's it. Not required, but by default there is an auto summary. That's why we are using this OSP. By default there is an auto summary. Huh? Yeah, recording is on. Then in the router 2 also, router OSPF, and doesn't matter. The network 192.168.1.0, then wildcard mask in the area. Okay. So IP OSPF neighbor. This states we will discuss on the Monday. We have some 7 state, we have some message type. The things we will discuss on the Monday. Just I am going to prove you these things. Only this manual loopback and the interface one. Only this task. You can see 1.1 it's saying is a DR. But according to our thinking, our concept, our BDR is a, our R2 is a DR. So why here it's saying the router 1 is a DR? You can see this is a first one. First thing, just type so IP protocol. Router ID. You can see for the router 2, what is the router ID? 192.168.1.2. Why? Because we didn't configure manually. We don't have any loopback IP address. We have IP address. So our IP address will become a router ID. In the router 2, we have only one IP address. So that IP address has become a router ID. In the router 1 also. So IP protocol. Router ID. Because in this router only we have only one IP address. Now we have to verify the cost. As I told you, like we have a by default one, and that priority is belongs to interface. In each and in the interface, we have different priority. So IP OSPF interface F0 by 0. This is the command. Priority 1. Write it down the command. So IP OSPF interface. So IP OSPF. So IP OSPF interface F0 by 0. Can be anything F0 by 0, G0 by 0, F0 by 1. Depend on your topology. Clear this one? Now in the router 1, when I'm typing so IP OSPF neighbor. So it's saying this is my neighbor router 192.168.1.1 and it is a BDR. But according to our concept, it must be DR. So why it's saying it's a BDR? Why? Because we configure the R1 in the first, then it's sending some message, okay, no one is there, so I am a DR, I am a DR, I am a DR. And after some time, I configure my router 2. So it's saying, okay, already I have one DR in my environment, so I'm not going to disturb my topology. I'll become a BDR. Compromising. I compromise myself. Okay, no issue. You are DR, accept it. But I don't like this, na. So interface F0 by 0, come to the interface level. Here also come to the interface level. Interface F0 by 0. Do one thing, fire, shut down. Here also shut down. Okay. Now just fire, no shutdown. Then election will be happening. It takes some time. So IP OSPF neighbor. It's taking some time, so I can fast forward this. Now you can see it's saying neighbor ID. Neighbor ID, it means your router ID 192.168.1.2. This router ID belongs to which router? Router 1 or router 2? Router 2. And this router 2, what is the priority? 1. And it will become a DR. And it's connected with this interface. check. So IP the OSPF neighbor. Yeah, 1.1 it become a BDR. Okay. Now what I'm going to do here, I'm going to configure one loopback here in the router 2. Router 2, yeah. Router 2 is my DR. Okay. So I'm going to configure one loopback interface. P interface loopback 1. IP address. It's very high IP address 1.1.1. 5.2.5.5.5.5. Then now just tell me what is the router ID for the router 1? Router ID.
Loopback interface.
Interface IP address now because we didn't assign any loopback here. 192.168.1.1. It's better to write down here. The interface IP address 192.168.1.1. Here interface IP address 192.168.1.2. And we created one loopback 1.1.1.1. Now just tell me what is the router ID for the router 1? 192.168.1.1. What is the router ID for the R2?
1.1.1.1.
So
Loopback
I'm
interface.
just asking.
That will be the right.
Yeah.
1.1.1.1.
Yeah, 1.1.1.1 is the router ID for the router 2. So come to the again router 2. Configure my loopback interface. Check the IP address. So IP interface brief. We have two things. So according to our theory, this 1.1.1 is my router ID. So IP protocol. Still router ID is 192.168.1.2. Again, it's not going to disturb. Like, okay, router ID is 192.168.1.1. Leave it. Compromise. Again. So do one thing. Save your configuration. Reload your address.
After setting,
Enable. So IP protocol. Now, what is your router ID? Second time, say okay, and this time I'm not going to compromise. We have two election. There is election person. Okay, so router ID is 1.1.1.1. Now, the interface F0 by 0. Here also, the interface F0 by 0. Again, I am going down. Here also, shut down, then shut down. Now just tell me who will become a DR and who will become a BDR.
R2.
R2 is a DR or BDR?
DR.
R2 is a DR or BDR? BDR. Yeah, according to your DR. For the DR election, we have first is a priority. Priority is same. The second thing is router ID. Who has a router ID? Higher router ID. Router 2 is a 1.1.1.1. And the router 1 is a 192.168.1.1. R1.
Consider that it is R1. But we are considering first loop, no.
As I told you, like there is a election process for the router ID. So in the router 2, there is a one internal election happen for the router ID. Now loopback IP is a router ID. Now just tell me who has a higher router ID, router 1 or router 2?
Router 1.
Router 1. Okay. Router 1 has have a higher router ID. So router 1 become a DR.
We are fighting for deciding for outright.
Yes,
Yes,
internal
like
connect.
higher one.
Yes, internal that election happens. Internal competitions. So IP OSPF neighbor. You can see 1.1.1.1 will become a DR. It means router 1 will become a DR. Come to the router 1 and check. So IP OSPF neighbor. What is the router ID? 1.1.1.1 become a BDR. Why? Because it's a lower router ID. Okay. First internal election, then external election. Okay. So now, again, router come to the router 2. This time, I'm going to assign my manual. This one is clear?
Yes.
Yeah. And router ID is a router ID. It's not an interface level. It's a router level. So your priority is the interface level. Router OSPF. Which process number we use? So IP protocol. 10. Okay. So router OSPF 10. Very simple command. Question mark. You can see router ID in the IP address format. You can assign anything 10.10.10.10. Now you can say it's asking like reload your device or use this command for apply these changes. You can use the command clear IP OSPF process. You can write it down this command first, router ID. First you have to come into the router mode, router OSPF process 10. Then you have to change your router ID.
Most two values does not matter, then why we use it?
The CCNA doesn't matter. CCNA doesn't matter, but the CCNP, CCI will matter. Then now Control Z. Like see, I am in a router mode. If I want to become enable mode, directly type Control Z. It will become an enable mode. Now, so IP OSPF, so IP protocol. Your router ID is still 1.1.1.1. So our router said you have to fire one command. Clear IP OSPF process. Reset all the OSPF process. Yes. Adjacency falsely reset, interface down. Now check so IP protocol. Router ID is 10. Now just tell me who will become a DR and BDR. So for the router one, what is your router ID? Router ID. For the router one, we configure in the router two that. In the router one, we have only interface IP address. 192.168.1.1. What happened? You are feeling sleepy? Okay, in the router 2, we configure manual one 10.10.10.10. So what is your router ID? 10.10.10.10. Who has a higher router ID? So definitely your R1 will become a DR and this one will become a BDR. So again verify. We need a verification. Without verification,
If we have to decide the way, then we have to do the higher IP.
you can change the priority. No? Priority is remain left now. Yeah, easiest task is left. First, we have to complete our hardest task. Interface F0 by 0. Designated route. Don't ask for the full form. Just go ahead and Google it. Interface F0 by 0. Then shutdown. Then fire. No shutdown. Yeah. No shutdown. Now let's wait for the election. That takes some time. It took some time. So it's a Cisco packet tracer. So we can fast forward our process. But real time we can't. Come to the R1. Type so IP OSPF neighbor. So 10.10.10.10. It means router 2 will become a BDR. And router 1 will become a DR. DR. Yes? So IP OSPF neighbor. R1 is a DR. Here? The last thing.
This the interface which is designed with the last, it is our own.
This one. This is our own. We don't know about the neighbor interface. We don't know. We know only IP addresses. Physical things, I know only one. So So your this router 2 is a BDR and the priority is 1. Okay, now I'm going to change my priority. The last task of the today class. First, this clear how to this router ID election has happened. How to change your router ID? Clear? No doubt. So now I'm going to change my priority, and the priorities belongs to this particular interface. So we have to come in interface mode. P interface F0 by 0. IP OSPF priority 0 to 255. Okay. 01 we'll discuss on the Monday. Or if we have time, then we'll discuss it. So now just assign to the priority 10. Done. Just come to the interface mode and the type IP OSPF priority 10. That's it. Okay. Now just check again information. So IP OSPF now is a priority 10. But still, this is a BDR. Why is not going to disturb your topology? So there is one command config. Again that fire that command. Clear IP OSPF one. Clear IP OSPF process. Yes. So IP OSPF. Now you can see the router 1 will become a BDR. How can I verify? Just type here so IP OSPF interface F0 by 0. This is your set it to the DR and the priority is 10. Okay. Guys, any doubt, any query?
So for sir, election is going through that one by one, like first interface, priority.
Is going to check this process.
Yeah.
First, it's
Priority.
going to check your priority by default is 1. If you change to the higher, then it's going to prefer the first one. If your priority is matched, then it's going to check your second parameter. For the second parameter, also we have one internal election. It's going to check who, like how can we find our router ID.
Yeah.
First is going to check the manual. If we didn't configure our manual router ID, then it's going to check loopback. We don't have any loopback, then it's going to check the router her interface IP address. Okay, this is your process for the DR-BDR election.
And
Cast vote, no?
Cast vote?
cost. Also, I want also know the cost calculation.
Elections happening in the like any other like
Okay.
parliament. Okay. So if any like situation happen like they were like equal majorities
Okay.
and there's
Yeah.
there's a vote known as cast vote. That vote is based on like VP.
Who has a lower caste, it will win.
No, that that vote is based on vice president or like chairman of that sabha, and he will cast the vote and he will decide.
He's trying to say like all entries are selected. Among
Not
the
selected,
entries-
they get the equal majority, like equal number of votes. Then we need a cast vote, right? If it-
Okay, sir, I guess clear this one.
No, sir, you explain voice.
Why, sir? Is it not
Not able to hear properly.
that was this is not a OSP of time, this is a different one. It's a general knowledge.
Okay.
This one is clear. DR-BDR.
Yes, this one is clear.
Okay. Okay, then see you on Monday. Okay. Enjoy your weekend.
Okay.